So in this video, we're going to be talking about segments, rays, and distance between 2 points. So just to warm up for these few, let's write these down and fill in the blank. So pause the video, write them down, and fill in the blank. Okay, so after you've done these 4 problems, we have at least 2 points create a line. Okay, that's what we need. We need at least 2 points. And then at least 3 non-collinear points create a plane. Okay. 2 lines intersect in a point. And then 2 planes intersect in a line. This is some review from our last class. Okay, so a line segment. So a line segment is a piece of a line, but it is a portion of a line that has 2 endpoints. So drawing a line segment can look like this. We have points A and C are endpoints. Okay, so these are endpoints. And how we name this line segment, we name those 2 points and we put just a line above it. So no arrows on that line. Or we could write that as CA. So the 2 endpoints with that line bar above it. Now we're going to talk about a ray. A ray is also a portion of a line, but a ray starts from one endpoint and extends infinitely in one direction. And so you must have 2 points in order to create a ray. So make sure we're writing these down. So here's an example. I have one endpoint, which is A, and if it's extending infinitely, what's the next point it goes through? It goes through point C, so I can name this ray as A through C, but I'm going to draw an arrow to the right to show that it's a ray. Or we have C, and that can go through P, so I can say CP is also a ray. So these are 2 different rays. Guys, look at this. They have the different starting point. They have a different endpoint to begin with. Opposite rays now are 2 rays sharing an endpoint that extend in opposite directions. Okay. 2 rays sharing an endpoint that extend in opposite directions. So opposite rays, if we're looking at points R, S, and T, we can say all these points are collinear. So we have a ray. We could say, let's start at S and let's go through T. So this is ray S, T. But we could also start at S and have an opposite ray, and we can name that ray SR. So even though SR in the picture is going towards the left, the notation is still the arrow going to the right. So notice how we have the same starting point, which is S, but they're just going in different directions. So let me write an example, or let's look at this diagram again for a different example. I can name a ray that has 2 common points, right? We could say, what if I started at ray R and went through S? This is ray R, S. Okay. This is a different, RS, if we started at, and we went to SR, these are not opposite rays. Because notice how we are at a different starting point for these 2 rays. This ray on the left starts with R, and the ray on the right starts with an S. Okay, so let's look at this. We have these two questions. Is segment AB the same as line segment BA? So line segment AB is this. Is that the same as line segment BA? Yes. How about this one? Is ray AB the same as ray BA? Ray AB, so we're starting at A, going through B. Is that the same as starting as B and going through A? No. So those are different rays. Could we name ray AB in another way? So if I started at A and I went through B, I also have to go through C. So this can also be rewritten as ray AC. So ray AB and ray AC are the same ray. Okay, so now we're going to talk about measuring distances. So distance is the length between 2 points. So to measure how far apart two geometric objects are, that's what we do to find the measure. So if we wanted to find the distance between 12 and 27, if we think about a number line, 12 can be over here and 27 can be over there. The distance between them, we do 27 minus 12 to then get 15. So the distance between 12 and 27 is 15. Now, if I called these points, or name these points on a number line, so here we have K, L, M, and N, we can find the measure of segments or the lengths of segments. Okay, so if I'm asking what the coordinate point of K is, I'm looking at K, the number associated with K is -5. And then for N, the number associated with N is 3. So to find the distance between them, we have the number line and we can count. We can go 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 units is the distance between them. But if we're looking at this, and these numbers were much further apart, this could be a little different to do leapfrog on the number line. So a way we can find the distance, we could say, all right, -5 minus 3 gives us -8. But remember, we could take the absolute value of that because absolute value indicates distance. So we can just take the coordinate points, subtract them, and then take the absolute value of those points. Okay. And then here it says find Kn. And notice how there's no bar above it. So this is a new notation. When you see 2 letters that say Kn, that means find the length of Kn. Okay, so if I want to know the length of Kn, if I drew a line segment starting at K and ending at N, the length of that segment will be 8. So segment length, let's look at 2 different ones. So the length of line segment MN from starting at 2 and I'm going to 3, I could say -2 minus 3, take the absolute value of that, and I get -5. So I get 5. But this notation here, the length of MN, can be rewritten as just MN. So if I see MN without the bar above it, we know that's asking to find the length of the segment. And I know the length of the segment is 5. All right, so if AB, without the bar above it, so the length of AB is 4, and the length of CD is 4, then don't we know that these lengths are equal? Okay. So if 2 segments have the same length, then we could say these segments are congruent. So this is a new word that we have with geometry. And congruent means Same size, same shape. So these two segments are the same shape. They are both line segments. And they have the same size. So congruent. So we can say that AB, the line segment, is congruent to CD. So the congruent symbol looks like this. Got a little tilde with an equal sign. Congruent. Okay. So we can mark congruence on a diagram. And notice how we have tick marks on this diagram. Okay. So we have two line segments. We have X, Y, and ZA, and then they intersect at point C. But notice how we have from X to C, we have this single tick mark, and then from C to Y, we have this single tick mark. So if we see two segments with the same tick mark, that means these segments are congruent. So I can say, all right, line segment XC is congruent to line segment CY, since they each have a single tick mark. And then if we look at the other piece, notice how these two segments have two tick marks. So I can say ZC, that segment is congruent to CA because they have two tick marks. And then the other one had one tick mark. Okay, so we're going to practice with congruence all throughout the year. This is a new idea, so we will go through questions that we have in class together.